everybody, welcome to an impromptu episode. Working on a lot of things, but the thing that I want to share through this episode is about these current transformers, otherwise known as electricity sensors. Basically, it's a non-invasive way to measure current going through a wire. They open up like this, so you don't have to cut any wires or do anything like that. You pass a conductor through here, and then you close the lid on it. And what that does is when electricity passes through it in a specific direction, it creates a voltage in a transformer, which is output on these two leads here. So this is what is used in most, if not all, of the current sensing apps or products that are on the market that you can install in your breaker box in your home or in other places to monitor your electricity consumption. And this is something that I am interested in monitoring in my home. And there are products on the market that do this, but they're expensive. You're talking $300, $400, $500, sometimes $1,000, depending on the system that you go with. And I don't necessarily mind paying for a well-made product that gives me the information. A lot of these have very slick apps where you can monitor your electricity usage and things like that, with varying levels of smartness built in of detecting, wasteful power and things like that. I'm not so much interested in learning on how I can save electricity, although that is an added benefit. I feel like we operate on a very low amount of electricity in my house, LED lighting throughout the house, and we're good about turning the lights off and things like that. But I just like it from a data perspective to see, analyze what kind of patterns there are and maybe find ways that we can be better on that. But mostly it's just to nerd out on the information. Things like understanding like how much different systems are using AC. I have 2 AC units on my house, like seeing how those work and how much energy they're drawing and things like that. But and so I'm not opposed to buying a product and using an app, but there's a couple problems. The price is high for understanding how it works. Again, it's just a couple of these sensors in your box and then they're reporting data back. But the big reason is because I haven't found one that allows you to access to the information directly. You have to get it through their app, and if you want it, you have to get it through their cloud. You're sending your data to them, and I understand why they do this, and some of them charge a monthly fee for this sort of thing, where you're paying to have them hold your data and be able to, bring it up on your phone because it's in their cloud. But I don't like the idea, especially if I wanted to integrate that knowledge into other parts of a home monitoring system. I don't like having to send it to your cloud, then grab it from your cloud, which many of them don't even offer. You can't even access the data, and that's a topic for a whole different video of, who really owns the data that you generate. I'm generating electrical data, but some random product owns that data and can use that to monetize it and sell to other companies. And anyway, different video. I don't like having to go out to somebody else's cloud to grab my electricity usage data. And so I said, you know what, it's just these. How hard can it be to hook this up, get some sort of voltage out on these 2 pins, connect it up to an Arduino or a Photon or some other platform, ESP32, and I can get the data myself. I can store it however I want. I can look at it however I want, and I get to nerd out in the process. And so that is the project that I'm working on. And so I bought this current sensing, it's called a current transformer from SolarEdge, and it's just a rebrand of the product that's sold by C Control Systems. And I'll just give you an up-close look at that. Hopefully it focuses all right. And a little pricey. These, you gotta be careful when you're buying these. You can find these all over the internet if you just do a search for CT sensor. And this same kind of sensor can go anywhere from $25 to $100. And it's all just the same thing. There's not really a quality. They're very simple devices. And so it's just, if you're gonna look at buying one of these, be careful where you're going. You might overpay for something that's the exact same product that somebody else is selling for half as much, which is what I found. I was gonna pay like $70 a piece for these, and then I found from SolarEdge the exact same, and I mean like everything, sticker and everything except without the SolarEdge, was twice as much at another place. I found at SolarEdge I paid $34 a piece. You buy 2 of them because you have 2 leads, main leads that come into your breaker box. That's usual, at least for here in the United States. And so for whatever that is, $68 plus some shipping, I've got these 2. I went to hook it up And I misread the label. If you see there, it says 200 amp, which means it can read a maximum of 200 amps, and it says 0.33 volts AC. And it's got a little division marker before it. What I thought that meant was for every amp of current that it detects, you'll get 333 millivolts out. So for 1 amp, you get 333 millivolts. For 2 amps, you get 666 millivolts, et cetera, et cetera, et cetera. Then I did the math and I got worried because I was like, Jesus, 100 amps. I have 200 amp service in my house, but if I'm pulling 100 amps, this thing would be outputting like 33 volts AC, 60 volts AC at full load of the sensor. But I was mistaken. It's actually 333 millivolt AC is the max output at 200 amps. And so for just something like some lights in the office here, at pulling an amp for some of these fluorescent photo bulbs that I have, it's going to output a very, very, like 3 millivolts down at that low range. And so the signal is extremely noisy. I hooked it up to my oscilloscope because I hooked it up to my meter. I wasn't seeing the things that I was expecting. So I hooked it up to my scope. Still was like, it just looks like mostly noise, and realized, goodness, you can't just plug this into an Arduino and start getting your sensor readings. And so where we're at is we need to what's called amplify and condition this signal. This is very common when you're dealing with analog sensor signals. They're very low, they're very accurate, but they can be very noisy and very small. And so to read them with a platform, what you need to do is condition them, which means remove a lot of the noise from it that you're going to get, as well as amplify it. So for 1 millivolt at 1 amp, that's going to be really hard to pick up on the analog to digital converters that are in most of your common maker platforms. So you need to boost that signal. You also need to DC offset it. This is an AC signal, so when it says 333 millivolts, that's AC, which means it's going to positive 333 millivolts to negative 333 millivolts. And it's doing that. Well, again, all these maker platforms, they have to read that analog signal from 0 to VCC, or the platform voltage. And so your Arduino is not going to register negative 20 millivolts. So you have to take that oscillating signal like this and boost it up above 0 so it oscillates to some higher voltage, like 666 millivolts down to 0 millivolts. So providing an offset. So all these things you have to do, which is why companies are making products that you can plug these into. Now, the same company that sells these sensors, SolarEdge, or actually CC or C control systems, sells a box that you could just plug these leads into, and you can get out different RS-45 signals, Modbus signals, or even pulse signals that I could then read as a consumer without anybody else's cloud. Those things are very expensive. I'm talking like $300 just for the box plus the sensors. I'm back to just buying a product and doing it that way. So I'm going to try. I don't know how effectively. I'm really disappointed in myself because I have an electrical engineering degree and I did this stuff in college, but that was a long time ago. But this is the type of circuit that you would build in a lab during getting your EE degree to be able to condition and boost a signal like this. And so I'm going to try and do that with the help of the internet and see if we can take this sensor and read it with something like an Arduino or Photon or some other maker platform. And then, share all that information out for somebody else that might want to just kind of maker hack something like this, where they don't want to buy a product and use an app and use the cloud and things like that. So that's what we're working on. A lot of information there. I can't remember if I specified this at the beginning of the video, so I'll cover it again and then just cut it out if I already covered it. But the way these work is that when the current passes through the conductor that's coming through the hole here, the current creates a magnetic field in a very specific way that the transformer picks up in the coils inside of here and then generates that voltage here. And so that's the principle of how these work, so that you don't have to cut any wires or put anything in line. You just wrap this around a conductor, and sensing that magnetic field, it turns it into a voltage out on the other end here. And that's the operating principle of how these sensors work. So that's what we're working on, and I'm going to explain a little bit of how we're going to condition it for this video, and then I'll kind of keep you up to date on how the project's going as we move forward. All right, so I'm going to go super low tech here and just video my monitor. So sorry for any flicker that you see here, but what we need to condition our signal, we need to rectify it, which means we can change it from an AC signal that's going up and down like this and turn it into a DC signal, which is what our maker platform board can better read with the analog to digital converter. And so to do that, we need a circuit like this called a precision rectifier circuit. And so basically the signal from the current transformer comes in here. This rectifies it, so it's more DC component than AC, and then you amplify it with this second stage. These two things, these LM324s, are called operational amplifiers, or op-amps. And so that's it. And then we choose values for all these resistors here, and hopefully at the other end, on the far right there, we come out with a filtered, conditioned, amplified signal from the sensor that we can read with a platform. I have no idea how well I'm going to be able to make this work, but the first thing I need to do is order some of these LM324s, these op amps from DigiKey, and so that's what I'm going to do today. I'm going to order those, and as soon as we get them back in a future episode, we'll try and assemble a circuit like this, hook it up to our oscilloscope, and see what we get. All right, so that's it. That's all I want to do for this episode. Again, I'm going to try and keep you up to date on this project. It's kind of a fun side project. For those that have been watching the channel, still working on the hockey puck, still working on a lot of the tech around that. Lots of things happening there that I'm not going to cover on the channel here because it's just a lot. There's a lot of things going on with that be hard to make videos on. But this is a great side project that just in my spare time, like I said, I'm going to order those parts, wait for them to come in and just work on that. But I wanted to share it to show kind of the process. I have no idea if I'm going to get to a working power monitoring solution at the end of this, but just figured it would be something fun to do. And again, I've bought the sensors. I'm already $70 into it. I might as well go the rest of the way to see if I can get something working. So thank you so much for watching. I really appreciate it. And tune in next time to see where we end up once I get the components in.